Okay, basic limit laws. We have 5 basic limit laws that we need to know, and this is how they work. As long as the limit as x approaches c of a function f of x, and the limit as x approaches c of another function, g of x, exist, these 5 laws will work. The first law is called the sum law. And it states that if you have the limit as x approaches c of the addition of those two functions, f of x and g of x, if that exists, and as long as that exists, the limit as x approaches c of those sums will be equal to the limit as x approaches c of each individual piece. Here's an example of the sum law in action. If you have your two functions, f of x is equal to 2x plus 5, and g of x is equal to sine x over x, and you go and try and find the limit as x approaches 0 of f of x plus g of x, you can take this apart. It would be first function plus your second function, and taking this apart gives you the limit as x approaches 0 of 2x plus 5, as well as the limit as x approaches 0 of sine x over x. The limit as x approaches 0 of 2x plus 5, we saw this one last day, something similar using a numerical approach. This one is equal to 5, and using a graphical or numerical approach to sine x over x, you will get 1, and so the answer to this is 6. Second law is called the constant multiple law. And the constant multiple law states for any value k, the limit as x approaches c of k f of x exists, and it can be also written that the limit as x approaches c of k f of x is the same as k times the limit as x approaches c f of x. That constant value can essentially factor out. Let's take a look at an example of this one. How about the limit as x approaches negative 1 of 2x plus 5, and we can take this apart because it's the sum, the limit as x approaches negative 1 of 2x plus the limit as x approaches negative 1 of 5. That's 2 times the limit as x approaches negative 1 of x, and this is a constant function, so it's equivalent to 5. And we learned yesterday or last class that we can simply do a substitution with the value of x. So this is 2 times minus 1 plus 5. And here we see why these linear functions all work. Because using this law, essentially you just factor out the 2 and substitute in the negative 1. and multiply the 2 back in. It's a much faster way just to have originally put in the -1, but this law will be useful lots of times. Law 3 is known as the product law. And the product law states that if the limit as x approaches c of f of x times g of x exists, then the limit as x approaches c of f of x times g of x is equal to the multiplication of the limits. The limit as x approaches c of f of x times the limit as x approaches c of g of x. Here's an example of how this one works. If we have the limit as x approaches 3 of x squared, that's the same as the limit as x approaches 3 of x times x. So we can break this into 2 parts. The limit as x approaches 3 of the first x times the limit as x approaches 3 of the second x. We know we can do substitution and get our solution. Law 4 is similar. It's called the quotient law. And the quotient law states that if the limit as x approaches c of g of x doesn't equal 0, then the limit as x approaches c of f of x over g of x can exist. And that limit as x approaches c of f of x over g of x is the same as applying the limit to the top and the limit to g of x. And you can notice why we had the restriction that the limit as x approaches c of g of x can't be equal to 0. Otherwise, the denominator here would be equal to 0. An example of this is the limit as x approaches 5 of 2x minus 1, there's your f of x, and x plus 3, there's your g of x, and you can separate this out into the limit as x approaches 5 of 2x minus 1, all divided by the limit as x approaches 5 of x plus 3. As we've seen in the past, we can simply do substitution. So you get 10 minus 1, which is 9, and 5 plus 3, which is 8. And finally, we have our last rule, Rule 5, known as the power rule. It's also good for roots. Because roots are a form of a power. And the power rule states if p and q belong to the set of integers and q doesn't equal 0, then the limit as x approaches c of f of x, all raised to the power p over q, exists. So p and q have to be integers. Q can't be equal to 0 or else it will be undefined. If that's true and they all exist, then the limit as x approaches c of f of x raised to the power of p over q is is equal to the limit as x approaches c of f of x, find that answer and raise that to the p over q. So, for example, if you have, what is the limit as x approaches 2, and 3x minus 4 all raised to the negative 1/3. And so that's exactly the same as the limit as x approaches 2 of 3x minus 4, and the solution to that raised to the negative 1/3. So substituting it in the 2, I get 6 minus 4, and 6 minus 4 is 2 to the negative 1/3, and that's equal to 1 over the cube root of 2.